Experiments in Physics with Dr. Frank Oppenheimer. A brief demonstration of the equipment used in the Library of Experiments in Physics, produced in cooperation with University of Colorado Television. Today's experiment
in this experiment, one can measure the ratio of the specific heat at constant pressure, the specific heat at constant volume, the quantity called gamma, of a variety of gases. This is now filled with air, and that's done by studying an adiabatic compression of a gas. The compression is produced by a small ball, which is a loose fit in this glass tube. I can show that ball to you by blowing it up there and then letting it drop, and you can see it fall. When one blows it up, here is a glass mouthpiece, which you can wash off before you use it, and a piece of capillary in here, which should be left in so that you can't blow too fast and crack the tube by making the ball hit the top. At the top is an electromagnet, which is actuated by this button, so that when I blow it up there and push the button, I can hold it up there as I wait. Now, having blown it up, I'll wait a moment until the pressure is equalized and any temperature changes are gone, because I will have to know both the pressure and the temperature on the gas inside here. Having done that, I'll pinch this off as near to the inlet as possible. And now the ball, when I release it, will drop, and in doing so, it will compress the gas. Let's see how far it'll drop. To about here. In doing that, it compressed the gas from that point to here, which is did amount of work mgh. It also did an amount of work which depends on the integral of pdv, the pressure times the increment of volume on this gas. And if one knows the total volume and the fraction of dv here, one can equate those two works and calculate what what gamma must have been, because the compression depends on the fact that P times V to the gamma is a constant. One should repeat that several times. Let's see how reproducible it was. It came to about 37.5 the first time. And I'll try that again. See whether it comes to the same point. Yes, very closely, so that there seems to be no trouble. Before one does the experiment, of course, one has to be sure that this ball isn't sticking, and there are two reasons why it could stick. One is that the tube wasn't level, and so the first thing to do is to level the tube, to set this groove in one of these levels against the glass and make sure that it's level, and use these screws down on the base here to level it. Of course, one wants to try it in all directions. If it still sticks when it's level, it may be that there's some lint in there, but it should be moved very freely when that's open, and if it does, it doesn't need cleaning. If it sticks, then you'll have to get somebody in charge of the lab to clean this out with a swab and some acetone. In addition to the method of seeing how far this falls when you release it and producing that kind of compression, one can also measure the period of the ball when it falls down here. And this gives a second method of measurement. I'll put it up there. Wait a moment and then clamp this off. And then use a stopwatch and release it and start the watch when it hits the bottom. 0, 1, 2, 3. And usually one can get anything from 4 to 6 oscillations, and get the period. But as you saw, this was fairly heavily damped, and it's probably worth correcting the period for the damping. That one can do in the following method. I'll put it up once more. Hold it. Now I'll let it go, and I'll see when it comes up to the top of its amplitude here. There, and now here's the equilibrium position. So you can see that this was the first swing, this was the second swing, and here's the equilibrium position. I think one can do that a little more accurately, but even that, which shows that the amplitude decreases by about a factor of 2 in one period, will give you an appreciable correction and enable you to get the true period from the actual measured period. In addition to measure the gamma for air, we have a second very similar apparatus, at least in principle, which can be filled with a monatomic gas, such as argon, and one can measure in exactly the same way this ratio of the specific heat to the quantity gamma for argon. Rather than flushing this one out, as one goes back and forth from air to argon, we keep the second apparatus full of argon and use the argon itself to blow the ball up to the top by turning a very gentle flow of argon on. One could also try other gases in addition to the argon if you're interested in that. I believe those are the main precautions to take about this experiment, and it'll illustrate the techniques used to do it. But be sure that every measurement you make, you do test how reproducible it is, because if the ball is sticking, you will get very inaccurate results.
Experiments in Physics with Dr. Frank Oppenheimer was produced in cooperation with University of Colorado Television. This is University of Colorado Television.